Hi folks, welcome back to Physics with Captain Rod. Well, we're going to talk about example 1 here in your physics notes under work done on a gas. So let's see, we got a gas that can expand from state A to state B along 3 different possible paths. What we're going to do is calculate the work done on the gas for each path and discuss heat transfers. So by state, what we mean is, like right here, we're at a certain volume, a certain pressure. In theory, we could calculate a certain temperature. Those 3 things together are what we mean by a state of the gas. And then here's state B, new volume, new pressure, probably new temperature as well. Now, there's basically an infinite number of ways to get from A to B. We could get from A to B all sorts of different ways. We're going to explore the 3 shown, starting with path 1. So path 1 is this path. And I've already wrote out the work here, and hopefully I got the math right on this. So remember, work is area. So the first work term is this area right here, which, if I did this correctly, is equal to this. 5 times 10 to the 5th newtons per square meter on the vertical axis times 0.005 cubic meters on the horizontal axis. That's coming from the difference in volume. All right, now let's talk about this path, or that part of it. Well, that part has a work of 0 because there's no area under the curve from A to B. You only get work, or only have work done, when you change volume. Just like, in most work problems, there's only work done when something moves, force times distance. Well, in thermodynamic problems, there has to be a change in volume. So the work done from along path 1 is looking like, if I did this right, 2,500 joules. Now it also just talks about discussing heat transfer. So as we look at this part here, as we move from A to B, it's important to recognize that we are moving to a higher isotherm. So that means that the temperature on the right is higher than the temperature on the left. But notice that the gas is expanding. The expanding gas should have cooled the gas, and it didn't. The temperature went up. That guarantees the heat transfer had to be into the gas. And that's how you would represent that on a PV diagram. All right, if we discuss the next part of the curve, all right, let's discuss this part of the curve. All right, from here to here, we also went to a higher isotherm, or in other words, a higher temperature. And there was no work done. So there also had to be a heat transfer into the gas, going from this point to this point on the PV diagram. Okay. Path 2, right? That's this one. So the work done is the area under the curve. So what you have to realize is the area under this curve is this stuff. And that's a trapezoidal area. And we've talked a little bit about how to find the area of a trapezoid, right? Left plus right divide by 2 times the width gives you the area of the trapezoid. And if I did that right, that should come out to 5,000 joules. All right, let's discuss heat transfer. So along path 2, we are also moving towards higher isotherms. But from from A to B along path 2, again, that's an expansion. And the expansion should have dropped the temperature, but it didn't. The temperature went up. Therefore, the heat transfer had to be into the gas along that path. Okay, path 3. That's this animal right here. So the first part of the path is this vertical chunk right here. And there was no work done because there's no area under the curve, hence the first 0 here. And then the work done along this path is this rectangular area right here, which hopefully I've done that right. All right, height times width, and I get 7,500 joules. Let's go ahead and discuss the heat transfers. Okay, from here to here, we went to a higher isotherm guaranteed. And there was no work done. So the heat transfer had to be into the gas along that path. And now we'll talk about this part of the path, moving from left to right. So looking at it again, when we went from here to here, the gas was expanding. The temperature should have went down, but it didn't. We moved to a higher isotherm. So the heat transfer had to be in this direction. So that should do it. I want to try to keep these videos short. Got another example coming up. I hope that this helps. Have a great day.